Hello students, and welcome to today's lesson on collecting like terms. So collecting like terms is very similar to adding polynomials, but this is the first step. So collecting like terms. So we're going to start by talking about algebra tiles and relating to how algebra tiles work with collecting like terms, why that works, and then moving from there into the algebra and only using the algebra. Some have already done the algebra, but I really encourage you to go backwards and start looking at the algebra tiles because they're going to help us when we get into multiplying and dividing and then some higher level factoring, which comes up in grade 10. So the algebra tiles can be very useful. They give us a concrete example of what we're doing. So just to review your algebra tiles, it's been a while since spring break. This is your x squared tile, is a big square. This is your x tile. Okay, your x tile is a rectangle. And then this is your one tile. Your one tile is the small square. And do you guys remember what the opposites are? The opposites are shaded. So in math, our opposites for math are negative values. So that is a negative x squared. This is a negative x when you have a rectangle that is shaded, and this is a negative 1 tile when you have the small square that is shaded. So do keep in mind those different types of tiles as we go about and do our drawing. So the first thing we have to talk about in order to understand like terms is this zero pairs principle. So zero pairs principle is basically the idea is that two opposites make a zero. Just like plus 3 and negative 3 would equal 0. Same idea with our tiles. So with our tiles, we have a positive 1 and a negative 1. Overall, this value becomes 0. So that is a zero pair. Then, of course, the other zero pairs would be our positive x tile and our negative x tile. So those two, of course, again, make a zero pair. And the last zero pair we have, it's the large squares. So there's a negative x squared, and here's a positive x squared. So those two, of course, form the value of 0. Okay. So if we have any numbers, we'll talk more about zero pairs now as we go back through our notes. But the zero pair principle is important. Zeros can be added or removed. They don't change values. We'll see that a little bit later on. So going forward then, let's talk about collecting like pairs. So we have a 3x, a 2x squared, a 2x, and an x squared. Basically, you think of this as everything has been thrown into a pot and mixed up. So for example, we have 3 x's. I can draw them in this orientation, or I could turn them sideways. It doesn't matter. I have 2x squareds. So there's 1, there's 2. I have 2 x's. So there we go. There's 2 x's. And I have an x squared. So those are all the pieces of the pile. What you want to do then is organize these tiles into a math system. And most of you, if we had the tiles on the desks, you'd be moving them around no problem. And so I can move these around as well. So I would probably move, these 3 right here. I'll be taking them and moving them over here and moving this over here. So now all my x squareds are grouped together. And then I'm probably going to group these guys together, which is exactly what I want you to do. That is collecting like terms. Now, you tell me, what have you got? Well, over here, we have 3x squared. And over here, we have 5x's. Now, my question is, are those positive x's or are those negative x's? What are they? Since they're unshaded, they're positive. So remember, our positive sign also is like a plus sign. They are one and the same. Okay? So when you're doing this, you're just going to group them all together and then tell me what you got. Same thing with this next question. Okay, so with this next question, you're going to go and draw the pairs. Oh, I'm using blue here. So I have an x squared. I have 2 x's. Now I can draw my x's this way if I want. That's fine too. I have a negative 2, so it's a small square that's shaded, and there should be 2 of them. And then I have a 2x squared. So there's 1, There's 2. Then I have an x. I'm deciding to draw it this way. No big deal. And then I have a -3. Okay. And often when we have our pieces, you're doing this as we speak, you're putting them together. We want to group them into a math system. So we group the same pieces together. So I would then have my x squareds together. I would have my x's together, and it'd all be neatly organized. Okay. Now again, I'm kind of hyper organizing this, but then you can see though the different pieces and where they belong. So those are all the pieces. Now you tell me, what have you got? Well, not only do you have to tell me how many there are, there's 3 of them, but you also have to tell me whether it's positive or negative. Now, if we write plus 3x squared, that's the exact same as 3x squared. So you don't need to put the positive sign. Here, what have we got? Well, it's the x tiles. And how many are there? 3. Are they positive or negative? Positive. So this represents positive 3x. And our positive sign gets written as a plus sign. It must be written there. Okay, so you cannot have this blank. You must have something that connects, either positive or negative, connects those two together. And what's left over here? It's negative, how many? 1, 2, 3, 4, 5, so it's a -5, showing that there is -5 1 tiles. Okay, so how did you group them? What system did you use? You group them by shape. Okay, you group them by shapes. Okay, so the system you use is you put all your x squareds together, you put all your x's together, and you put all your 1 tiles together. And that's exactly what you did. You just told me how many there were, and you could actually use your coefficients. Did you realize that? So for example, over here we have 3 x's, and then we have 2 x's. So how many altogether? There's 5. And that's what we're going to start moving into, is moving into using the coefficients, which some of you, of course, know how to do. Let's take another quick look here at like terms. So if we have like terms, right, that's how we group them, using like terms. And for the drawing the tiles, they were the same shape. Okay, so like terms have the same shape. This means they have the same letter and the same exponents on the letter. Okay. So which terms are alike in this little group of terms? So let's start with the x terms. Which ones are the x terms? Well, we have 3x and 7x. And that's because they have the same letter, same exponents. We also have x squared terms, which are different. So they are not the same as x's. So to show that they are different than x's, we will use a square box around them. So those are x squared terms. They are different. We cannot combine our x's and our x squareds. You see up here, we have to leave them separate. Exact same thing down below. You cannot combine them together. What about then the x squared y's? Okay, do we have any other x squared y's? Well, this is not an x squared y. This is not an x squared y. That's not an x squared y. So we don't have any. This is the only one. Okay. What about xy's? Do we have any other xy terms? Well, if you look over here, this is also an xy. This is the same letters and same exponents. So it doesn't matter which way you write it. They are the same. That's important to see. We will challenge you on that all the time, that these are the same. One is alphabetical, better way to write it, but the other one is the same term. Okay. What else is the same? Do you have any others? Well, you have this term right here, a xy squared or y squared x. I kind of gave it away. Those are exactly the same. So those are the same terms as well. Okay. So we can't combine unlike terms. So just to let you know, xy is like a yx. But, example of unlike terms, x squared y, that is unlike xy. It is unlike xy squared. Those are all different terms. Very important to know. Good. So, combining our ideas together now, what happens when we combine some more terms together that form zero pairs? So we have three x's. Here is 1. Actually, I'm going to draw my x's this direction. 1, 2, 3. We have a negative 3. 1, 2, 3. We have a negative x, so it's shaded. And then we have a plus 5. 1, 2, 3, 4, 5. So let's group them together. So when you're grouping them together, you're going to take them and move them together. So these guys can go over here. I'll deal with them in a second. These guys side by side. Now what forms is a zero pair? You have two opposites. That makes a zero pair. You want to write them side by side, circle them to show that it's a zero, and cross it off because they cancel out. Now, they cancel out to zero. You don't need them. Okay, they nullify each other. Here again, I have some other tiles that form a zero pair. So I will circle it to show the zero pair, and I will cross it off. Now what's remaining? What is still left over after the zero pairs are removed? Well, I have a 2x and I have a plus 2. Okay, so that is my answer, 2x plus 2. Oops. There we go. Any questions? Okay, so looking at the next one, let's draw our diagram. You try it first, press pause, then you try and draw it out. Now sometimes what I like to do, I'll cheat a little bit. There's my x squared. I have a negative 2x squared, so then I will draw it side by side because I know I got to pair them up eventually. Okay, so you can cheat a little bit as you draw. I have three x's right here. They are positive. I then have negative 5x, so I will draw them here, shade them in. And I'm drawing them side by side because I know that they're going to pair up. They're going to pair up and become a 0. Okay, or 0, sorry, I say that wrong. And then I have a minus 2 shaded, and that's from right up here. And here's a minus 3. Now you can draw them side by side if you want. They don't form a 0 pair. They're just increasing how many negatives there are. So what have we got all together then? Well, we have this forms a 0. It's gone. So we have an x squared. And this forms a 0. So it's gone. We have a negative 2x. And then we have a minus 5. Okay. So this is what we call descending order. And descending order means you are going from a term that is in degree 2. This is degree 2 term. This is degree 1 term. This is degree 5 term. This is the typical order we write polynomials. Not mandatory. It's just our usual. Okay. Now the opposite order would be descending order. Sorry, ascending order. Ascending order would be a negative 5, a negative 2x, and then a positive x squared. That will be ascending order. Sometimes we'll give you a question in this order just to see if you know how to deal with it. Okay? Any questions so far? It's good. So the next part then is using tiles. Doing this without tiles. I got to pause my recording. Okay, so this is the second part of the video, just to finish off the last few questions. So just review, here is the terms written in descending order and ascending order, so keeping in mind it's all based on the degree of each individual term. Okay, so going forward then, we want to be able to do this without using algebra tiles. So what we're looking at here is just add or subtract the coefficients. Okay, and so we're going to do some kind of organizing to put them in proper order. So let's go in descending order. We usually start with our x squareds. So here we have a plus 4. This sign is included with the 4. So you got to always be looking at the sign in front. This sign is a plus 5. So it's plus 4 plus 5. Altogether, what have you got? Altogether, you've got 9x squareds. Okay. What about our x's then? Our x's, we have plus 6 and plus 10. So altogether, we have 16 x's. And finally, then, let's have a look at our 1 tiles. Here's a -2, here's a -7. So what we have is a -2 and a -7. They combine to give us a -9. So you can see that our subtraction signs are the same thing as our negative sign. So when we're talking about them, we're pretty much talking about the exact same thing. Just like when we look at our positive and negative signs, our positive signs, they're like addition signs. So if we have a addition, that is just like a positive sign. So that's something to be cognizant about when you're collecting like terms, is you need to look in front of the coefficient and to see what kind of sign you have. Good. Try the next example yourself. When you've done that, then you can press play. So here is a positive 4 minus 10. So plus 4x squared minus 10x squared. Altogether, that gives us a -6x squared. Then we can look at our x tiles. Here is 4x, which means it's a positive 4x. Here's a -6x. So when you combine them together, you get -2x. Then we can do the same thing with our 1 tiles. So with our 1 tiles, here we have a -3, a +8, and a +7. So altogether, when we combine those together, we get +12. So our whole polynomial then is -6x squared minus 2x plus 12. That's our final answer for collecting like terms for all the above terms. Any questions? Oh, sorry, I'm not teaching a class, so I guess there won't be any questions. All right. Going forward to the next question, give it a shot. Now you have d's and d squareds. It's not going to change anything. Just go ahead and collect like terms. So how many d squareds have you got? -7. Okay. How many d's have you got? +7. And how many 1 terms have you got? +10. So we're collecting all our like terms. There we go, descending order. Okay. Look at the next one. This one's a challenge one. I've got things mixed up here. Give it a good shot. If you're done, complete it. Now watch the video, press play. So we have 5x squareds. How many y's do we have, or y squareds? Well, we have 1y squared. We don't need to write the 1 in front. If you do, it's not wrong. It's just something extra you don't need. And then what about this? 2x squared and minus 5y squared x. This is exact same as 5x squared y. Okay, so they are the same. So yes, you can combine those terms together, and you get plus 3x squared y. The best way to write it is just like this, alphabetically, x first. Not mandatory, it's just highly recommended. Okay, you could also write this as the exact same answer could be 5x squared plus 3x squared y. As long as the sign in front of the coefficient is the same and the coefficient is the same, it don't matter. So you could have it in different order. And of course, there's one more order as well that you could write. Okay? So they are the same. Good. Last little bit then, kind of an application. You add up all the sides to find the perimeter of the shape. So you would add this side, add this side, add this side, add this side, and then of course put them all together. So what you're basically doing is adding up the lengths of each line. So it's really simple, okay? It is 5x minus 4 plus 3x plus 4x plus 5x minus 2 plus 6x. So altogether, how many x's have you got? 5 plus 3 is 8, plus 4 is 12, plus 5 is 17, plus 6 is 23x. And how many one tiles? Negative 4 minus 2 is negative 6. So that is the polynomial for the perimeter of that shape, 23x minus 6. Until we know the value of x, we can't find a numerical answer. We have to leave it as a polynomial. Good. One more shape, very last question then. What is the perimeter of this shape? So what is the length here? This length is x. This is an x. This is an x. This is an x. This is an x. This is a 1, and a 1. And this length is x. Now altogether, you can do this in a short way. What's the length of this? If you look up top, you could kind of see that it's 4x plus 3. So you could do it the shortcut way of kind of combining it all together for that side length as you're collecting like terms for the perimeter. So then the perimeter would equal x plus 4x plus 3, that's the top, plus x plus 4x plus 3, that's the bottom, and that's all together. That's all four sides. So how many x's do you have altogether then? You have a total of 10x plus 6. That is your total perimeter for that shape. Good. If you have any questions, please contact me. Let me know by email or through Google Classroom, and I can answer anything you have.